Imagine a scene from our distant past. A lone figure stands silhouetted against a bruised and churning sky. This is Sir Reginald, a knight sworn to his king, clad from head to foot in polished steel. He is a walking fortress, a testament to human ingenuity. But the forces gathering above him are not human. They are elemental, cosmic. A storm of immense power is brewing, a violent conversation between the earth and the atmosphere. Sir Reginald feels the static prickle his skin, a strange, tingling warning that his senses cannot fully comprehend. He is a beacon on this open field, his helmet's crest the highest point for miles around. Then, for a fraction of a second, the universe freezes. A leader of invisible ionized air snakes down from the heavens, searching, seeking a connection. The lightning strikes. It is not merely a flash of light, it is a physical event, a torrent of electrons pouring down the path of least resistance. We see the knight's form illuminated, every rivet and plate of his armor glowing with an otherworldly incandescence. The world explodes in a deafening crack of thunder and a flash of pure white light. What is this magnificent, terrifying phenomenon we call lightning? Inside those turbulent storm clouds, a great separation is taking place. Tiny ice crystals and water droplets are tossed about by powerful updrafts and downdrafts. They collide, rub against each other, and exchange electric charges. This creates an enormous electrical imbalance, a giant battery in the sky. The electrical pressure, the voltage, builds to hundreds of millions of volts, straining the very fabric of the atmosphere. The cloud sends down a series of tentative branching feelers of ionized air, called a stepped leader. It travels downwards in jagged steps, seeking the quickest path to the ground. As it nears the surface, the powerful negative charge attracts positive streamers upwards from the ground, especially from tall, conductive objects, a tree, a church steeple, or a knight in shining armor. When one of these streamers connects with the leader, the circuit is complete. A massive surge of electrical current rushes upward from the ground to the cloud. This is the brilliant flash we see as lightning. His fate depends on a principle of physics discovered centuries later by the brilliant scientist Michael Faraday. We call it the Faraday cage effect. A Faraday cage is a container made of conducting material, like metal. When an external electrical field hits the cage, the electricity flows over the outside surface, treating the interior space as a forbidden zone. Your car is a pretty good Faraday cage. If it's struck by lightning, the metal body will conduct the current around you and safely into the ground, leaving you unharmed inside. A knight's suit of armor, particularly a full suit of plate armor, is essentially a wearable, human-shaped Faraday cage. It's a continuous shell of highly conductive metal. When lightning strikes the helmet, the electrical current encounters a path of very low resistance. Instead of trying to push through the highly resistant human body, it prefers to race along the metallic superhighway provided by the armor. He has unwittingly dressed himself in one of the most effective forms of personal lightning protection imaginable. He is encased in his own personal, mobile lightning rod. Even if the bulk of the electrical current stays on the outside of the armor, the knight is far from safe. As this river of electrons flows over the metal, it generates an incredible amount of heat. The armor would become momentarily, searingly hot. Imagine the small gaps in the armor, the joints at the elbows, knees and visor. The electricity might arc or jump across these gaps, creating smaller secondary lightning bolts that could pass through the knight's body. An arc jumping from the helmet's interior to the knight's face could be instantly fatal. The sound of the thunder would be apocalyptic, especially for someone whose head is encased in a metal helmet that acts like a resonant bell. The sound wave could cause permanent hearing damage or a severe concussion. The flash of light would be blindingly intense, causing temporary or even permanent vision loss. The knight would be subjected to a simultaneous assault of extreme heat, deafening sound, blinding light, and powerful electrical and magnetic forces. It would be a profoundly violent and disorienting experience. History is filled with tales of storms and warriors, but specific accounts of knights being struck by lightning are rare. The written records of the medieval period were not focused on such scientific curiosities. The Battle of Crécy in 1346 was preceded by a massive thunderstorm. While chronicles mention the terror the storm instilled, they don't give us a specific tally of lightning casualties among the armored French knights. There are documented cases of people surviving direct lightning strikes while in contact with metal. Park Ranger Roy Sullivan was struck by lightning 7 times over his lifetime, often while holding or wearing metal objects, yet he survived. A person caught in a storm on a modern golf course holding a metal club faces a similar risk. However, unlike the knight's full suit, the club offers no protective cage. This highlights the key difference. It's not just about metal, but about the shape and completeness of the metal enclosure. Having a small amount of metal is arguably more dangerous than being completely encased in it. The principles that could save our knight are the same ones that protect us today. We build skyscrapers with lightning rods, traveling cars and planes that are essentially Faraday cages on wheels or wings. So, would a knight in shining armor survive a lightning strike? The answer, supported by the laws of physics, is a qualified yes. Survival is not only possible, but in some circumstances likely. The suit of armor, by acting as a wearable Faraday cage, would conduct the vast majority of the lethal electrical current around the knight's body rather than through it. The metal that makes him a target is also his greatest protection. However, survival would come at a steep price. The knight would face severe burns, potential hearing damage, possible blindness, and the risk of cardiac arrest from the shock. Several factors would tilt the odds. A complete, well-fitting suit of high-quality plate armor offers the best protection. A wet knight on wet ground would be even safer, as the water would provide an excellent conductive layer and a better path for the current to reach the earth. If you found yourself in a thunderstorm, you would not want to be holding a metal pole, but being inside a metal car is the safest place you can be. The knight's armor is more like the car than the pole. In the final analysis, the armor is more of a savior than a killer. It turns a fatal event into a survivable, albeit horrific one. What should you do? Don't stand under a tall tree. Avoid high ground. If you're in an open field, make yourself as small as possible. And if you happen to have a full suit of 15th century plate armor handy, you might just have a better chance than anyone else around you. Science reveals that sometimes the most archaic technology can be an accidental marvel of engineering.